So I want to comment a little bit about your graphs. So let's take a look at this. I noticed that quite a number of you okay, sorry, let me see. Can you see this? Yeah. Okay, so quite a number of you. I'm going to zoom in here. Okay, so the solutions that you gave over here. Okay, then you gave values Okay, and I'm assuming that you got all these values. You got all these values from Desmos. Okay, so maybe you plotted the graph on Desmos. Then after that, you just clicked on the solutions, and then you found the the solution okay, the x coordinate Okay, so now the thing is this okay, what if this is an exam question and there's no Desmos to help you, okay, to figure out this one? So we need to know how to divide the boxes properly so that we know how to count each intersection. Okay, and so because of that, I want to draw attention to two very interesting people's graphs, and I thought that it's quite good Okay, so the first one is Liu's graph. So this is Liu's graph. Okay, if you can see okay, so if you notice his points of intersection, he doesn't give the decimal place, but instead he gives it in terms of pi. So 3/40 pi, 2/5 pi, 3/4 pi, 11/10 pi, 3, and this one 7/4. So they're all together 1, 2, 3, 4, 5, 6. So they are all together 6 intersections. Yang ini obviously is very senang 3/4 pi and 7/4 pi. So the problem is this, and this How did Liu get 3/40? How did he get 2/5? How did he get 11/10? And how did he get, I don't know what is that, 3/something. I think it's 3/8 Okay, so Liu, do you think you can explain to us how you got it?
Can, sir. So first I will use the 1/4 pi to divide 10 boxes.
Okay.
So one box is like 1/40 pi. So, and every 5 boxes I will plot the value of it.
Okay.
And the first intersection is like two boxes less than pi/8. So I will use pi/8 minus 1/40 minus 1/40 to get 3/40
Okay. So 1/8 minus 1/40 minus 1/40.
Yeah.
You get 3/40. Okay. I think that's quite interesting. Good. All right. And I assume that you do the rest okay. But thanks, Liu. So notice, guys, that this is the most important thing. The most important thing is the first thing that he said actually. Okay, which is you know that the scale kamu tahu bahawa skalanya adalah 2 cm to pi/4. There are 10 boxes, okay, that represent 1/4 pi. So you can actually calculate every box is how many this one, and what he did was he divided by 10. So setiap satu adalah per 10. He says 1/40 So this is 1/40 pi, 1/40 pi. The next one is the next one. Setiap kotak adalah tambah 1/40 pi. Okay, that's a very good. I think that's a very good explanation, Liu. Thanks. Okay, the other graph that I wanted to show you is Fadila's graph. Okay. So this is Fadila's graph for the tangent one, the one which is a little bit difficult Okay, and as I said okay, there's only one intersection. Okay, which sorry, I don't know if it's very blurred to you but over here, Fadila writes 21/20 pi, and then equals to 3.3 radian. Okay, so Fadila, do you think you can explain to us how you got this 21/20?
Yes, sir. Okay, so the scale on the x-axis is 2 cm to pi radian, so it's 1/6 radian So I take 1/6, I divide by 10 because there's like 10 mini boxes. Then I will get 1/60. And then when I look at the intersection and I cut it already, there's like 3 small boxes. So I take 160, I times with 3, then I will get 120. Then I take 1 pi plus 1/20 pi, I will get 21/20 pi. Then I calculate, I get 3.3 radian.
How do you change this 21/20 pi to become 3.3 radian?
times 3.142.
Oh, times. Okay. Sorry. Oh, yeah, yeah. Okay, times 3.142. All right. Sorry, it seems like a very bodo question, but actually, I don't know why I asked it. But okay. Thanks, Fadila. Okay, so again, you find that both Liu and Fadila are doing the same strategy. You use the scale given. Kamu guna skala yang diberi, and to find out how much is the value of every box, you divide it by 10. Sebab ada 10 kotak. I think Fadila says 10 mini boxes, right? Okay, fine. So you divide it by 10. So you know that each of these is the same amount. So if this is pi over 6, okay, pi over 6 is 1 over 6 lah. So 1 over 6 divided by 10 will give you 1 over 60, or 0.1666, 1 over 60 lah. Okay, then dia cakap di sini ada 1, 2, 3 boxes di mana this one. So dia kali dengan 3. So you times 3, you get about 0.05, or sorry, 1 over 20. Then he adds together with this 1. Okay, so same thing, both Liu and Fadila are actually making the same thing, which actually we should learn from. Okay, kita harus belajar dari diorang, because what if you get this question and then there's no Desmos? How are you going to figure out what is the value of the x? Because right now, what you're doing on your graph is you're just showing me the points of intersection, but you actually still haven't answered the question lah. Okay, so let's take a look at this. Hold on. So just now, what Liu did was he divided it by 10. Okay, he divided by 10, and then you get 1 over 40. So every box is 1 over 40. Fadila's one, because our scale is 2 cm to pi over 6. 2 cm is 10 boxes lah. Okay, 2 cm is 10 boxes. Therefore, one box is pi over 6 divided by 10. Okay, and as I said before, jangan bimbang pasal pi. Just, it's just a number. Okay, 1 pi over 6 bahagi 10, you will get, 1 over 6 divided by 10, you will get 1 over 60. So 1/60 pi. Okay, so that means every single box, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, every single box is tambah 1/60. Okay, you add another 1 over 60. So in Fadila's graph just now, the intersection was at the third box. So yang ketiga di sini. So ini adalah 3 kali 1/60. 1/60, which will give you 1 over 20. Okay, so the reading over here, okay, is pi di sini plus 1 over 20 pi. Okay, so dia adalah kotak ketiga. And that's how he got 21 over 20 pi. Okay, so the principle of dividing the 10 boxes is a very important principle. You not only use this in maths, okay, dalam kisah pi, but you actually also use it in Form 4 maths. Okay, how do you divide, every box so that you know this is 0.1, 0.2, or is it 0.05, 0.1, 0.15, and so on and so forth. Okay, so I hope that Liu and Fadila's explanation was clear enough. The key to this is to divide the number of boxes, okay, so that number of mini boxes, okay, number of mini boxes, so that you know how to find out this one. Okay, so for those of you that have already handed in the graph, what you can do is just fix your own graph where it is lah. Don't need to send in a new one. Tapi for those of you that still haven't handed in the graphs, okay, I would suggest that you kasih baik dulu, okay, perbaiki kamu punya graph, okay, and then make sure that you are giving me the intersection in terms of pi, okay, because if you give me the Desmos value, I mean over here as latihan memang boleh lah, but we also need to melatih how to do in terms of pi, okay, and then the other thing that I need to mention is a lot of you just gave me points of intersection, right? Points of intersection. And then you give me all these coordinates, okay? But actually the question is asking for state the solution. So the solutions, okay, are x equals to blah blah blah, x equals to blah blah blah. All the values of x are the solutions. Okay, I repeat now, all the values of x are the solutions. This is what I am asking for. Okay, so for those of you who haven't finished, who haven't handed in this graph, who haven't uploaded the graph, okay, so that means minus the 12 people lah, sebab the 12 people are already done. I think the 12 of you that have already finished, you don't really have to resubmit lah, unless you're very rajin and want to resubmit, sebab kau pantang salah, you can do that. Okay, but the rest of you yang belum lagi hantar, tolong go and fix your graph. Okay, go and fix your graph and make sure that your answers are in this format. Okay, this is the one thing that I want to do. All right, please turn with me to page 212 in your textbook. Okay, today we're going to be looking at the basic identities in trigonometry. Okay, the three basic identities. Now, there are many identities in trigonometry. Identities are mathematical sentences, okay, that link trigonometric functions. In this, trigonometric identities lah, okay, adalah one mathematical sentence, okay, that gives the relation between two trigonometric functions. Okay, so I'm not going to spend time doing the derivation of this one. If you want, you can read page 211. But my basic thing today is to introduce to you the three identities. The first and the most important identity is sine squared theta plus cos squared theta equals to 1. I use theta, but the textbook uses a lah, doesn't matter. Okay, but this is an identity. Sine squared theta plus cos squared theta equals to 1. The second identity is 1 plus tangent squared theta equals to secant squared theta. Okay, and the third identity is 1 plus cotangent squared theta equals to cosecant squared theta. Okay, so these are the three basic identities which we can use for two things. Okay, number one, to find values. Okay, and number two, which is pretty much the most important thing, is to prove other trigonometric identities. Okay, and this brings me, sorry, this is my favorite part of this chapter, honestly. Okay, proving other trigonometric identities, okay, is my favorite part in this chapter. Saya suka because to me, proving a trigonometric identity is like a puzzle. You know. Macam mana saya mau pergi daripada mula sampai akhir dengan menggunakan maklumat yang sedia ada. So it's like a puzzle to me lah. You know, we try and we manipulate this around. Now, one thing we have to remember about these basic identities, it is interchangeable. For example, sine squared theta plus cos squared theta equals to 1. I can bring the cos squared across to become sine squared theta equals to 1 minus cos squared theta. Okay, or I can bring the sine across and I can make it cos squared theta equals to 1 minus sine squared theta. So we need to learn how to look at this as fluidly as we can. Dia bukan stuck begitu saja tau. Dia boleh berpindah-pindah itu. Okay, and if the situation needs it to berpindah-pindah, then it has to berpindah-pindah. Okay, so these identities are there and it is very fluid as I said lah. Okay, every identity kamu boleh pindah-pindah mengikut kesesuaian masing-masing. Okay, so let's look at one type of question first, which is the finding values question. Okay, take a look at your self exercise 6.6. Okay, number 2. Okay, you are given, okay, cos theta equals to m. Okay, determine the values of the following in terms of m. Okay, hold on. Cos theta equals to m. Now, what did I tell you about this last time? Last time I said that if they give you a certain this one, the first thing you must do is form the right angle triangle. Okay, there is more than one way to answer this. Sorry, I need to tell you that there is more than one way to answer this. So the original way I taught you to answer is to find the right angle triangle. Okay, so let's say this is the right angle triangle, and here is theta. Okay, what can I put into the triangle? What values can I put into the triangle? Anybody?
M and 1.
Where is m and where is 1?
1 is the hypotenuse.
Okay, 1 is the hypotenuse and m
Is the adjacent.
is the adjacent. Okay, because cos theta equals to m is actually m over 1. So if this is 1 and this is m, what is my opposite value? You remember how to count this? What do we use?
Square root 1 minus m.
Okay, square root of 1, no, not 1 minus m.
M square.
Yeah, 1 minus m squared. Actually, 1 squared lah. If you want 1 squared, can lah. But 1 squared is 1. Okay, so again, now we come back to the original skill that we learned at the very beginning. Okay, which is the right angle triangle skill. Very important skill. Okay, so important. Because with this, as I said, with this we are already opening the doors to 11 other information. We don't even need to think about it. Okay, the first question is secant squared theta. Okay, let's go back. Before we do the square, let's find secant theta first. Secant theta is actually 1 over what?
Cos.
Okay, 1 over cos theta. Since cos theta equals to m, therefore secant theta equals to 1 over m. Dan oleh sebab itu, secant squared theta is equals to 1 over m, the whole thing squared. Okay, that's what it basically means. So actually is 1 over m squared. Begitu je. This is if we use the right angle triangle to do this. Okay, but okay, so the idea is this, ini secant squared theta bukan bermaksud the angle yang kita kasih squared, bukan. It is the value of the secant theta, okay, that we kasih squared. For example, if let's say cos theta equals to 2, what is cos squared theta? What is cos
4.
squared theta? Okay, cos squared theta will be 4 because dia adalah 2 kuasa 2. So it's very strange to us at the beginning because the square is suddenly in the middle. Kan? Biasanya we are very used to kalau squared kan dia mesti di hujung. So you think that this one cos theta squared begini. Kan you are thinking like that lah. Okay, but actually it is written like this. Okay, why did they decide to write it like that? Instead of writing it like this, you have to ask the mathematical gods. Okay, I have no idea why they wrote it lah. I suspect it's because they don't want to write so many brackets. Because guys, this one cos theta, cos squared theta, and cos theta squared are two totally different things. Okay, very different. This one is cos theta itu kita kasih kuasa 2. Tapi ini adalah kita kasih square dulu the angle, baru kita cari the cos of that angle. Okay, very different values altogether. So we cannot mix this up. Okay, so make sure you understand that the cos squared theta means you find the cos first and then you square the value. Okay, question B, sine squared theta. Okay, in order to find sine squared theta, we have to find the sine theta lah kan. What is sine theta according to this triangle?
Square root 1 minus m square over 1.
Okay, very good. So sine theta is square root 1 minus m squared over 1. But we don't need to write over 1 sebab over 1 itu is overrated. But this is sine squared. If sine theta is 1 minus m squared square root, sine squared theta will be just 1 minus m squared. Okay, kita kasih kuasa 2 the square root lah. So we will get just 1 minus m squared. Okay, question C, cotangent squared theta. Okay, cotangent squared theta. First of all, we need to find tangent theta. Okay, what is tangent theta in this case?
Square root 1 minus m squared over m.
Okay, square root 1 minus m squared So tangent theta is square root 1 minus m squared over m. Tapi cotangent theta is the terbalik of tangent theta. So it's m over square root of 1 minus m squared. And lastly, we have to square it. So cotangent squared theta is m squared over, yang ini kasih squared will become 1 minus m squared. Leave this alone. Don't touch. Okay. Now, can we use other values to find cotangent theta? For example, if we know the identity is this one, 1 plus cotangent theta squared equals to cosecant theta. Can I use this to find? Can. I mean, it's not wrong lah. Memang kamu boleh. Okay. But usually identities we try to elak lah because it's so long and so complicated. If there is an easier way to find things, why not use the easier way? Okay, the easier way is obviously use the right angle triangle. Okay, much easier to do lah. Okay, than just using the identities. We have to learn the identities, of course. Okay, we can use identities to find this, but it's a little bit more difficult lah. Okay, a little bit more complicated. Okay, let's try another question, number 4. Okay, you are given the triangle over here, P over here, Q over here, this is theta. Okay, and they say this is the angle of A. Okay, A, C, B. Okay, so A, 1 minus cos squared A. Okay, now this is where the triangle becomes very useful. Oh, sorry. Sorry. This is where the identity becomes very useful. Okay, can I do this 1 minus cos squared A, okay, without using the identity? Can, I can. Okay, what is cos A? A is here lah. This is angle of A. If this is P and this is Q, what is this value?
Square root q squared minus p squared.
Okay, square root of Q squared minus P squared. Okay, so cos A will be square root Q squared minus P squared over Q. Kan? No? Yes? Okay, yeah lah, obviously lah. So, cos squared A will be equals to Q squared minus P squared over Q squared. Kan? So, we substitute this into here and we will get 1 minus Q squared minus P squared over Q squared. Okay, and this one needs a little bit of simplification lah. Okay, if we simplify this now, oh my gosh, 1 minus Q squared over Q squared minus P squared over Q squared. Sorry, this is plus. Okay, this becomes plus again. So we will get 1 minus, this one will become 1, so 0. So last kita akan dapat P squared over Q squared. Very long way, okay, of doing this. But when you know the identity, hey, look, it's 1 minus cos squared A. Let's go back to our this one. 1 minus cos squared A is actually equals to sine squared theta. Okay, so instead of doing it the long way like this, kasih jadi dulu ini adalah sama dengan sine squared A. And from the triangle, you can tell me, what is sine A? Sine A is opposite over hypotenuse, P over Q. P over Q, therefore sine squared A equals to P squared over Q squared, which is the same answer that we got just now. Okay? P squared over Q squared. So this is where the identities become useful, because when you know the identities, you can take a shorter version. Okay, daripada kamu mengira panjang lebar begini kan untuk mendapatkan jawapan yang sama, and most likely di sini yang kamu akan buat mistake. Okay, most likely lah. This is where you will make the mistake. Okay, so this is where the identities become very useful to us. Okay, let's try question B. Cosecant squared A minus 1. Let's simplify this. Cosecant squared A minus 1 actually is equals to what?
1 over sin.
Use triangle. Use the identity. Don't even go there, Azim. you're going to open yourself to a lot of difficulty. Cosecant squared A minus 1.
Negative sine square A.
Are you sure? Nope.
Cotangent square
Okay.
A.
Is cotangent squared A. Be fluid, nah? Okay, be fluid. As I said before, be fluid in this one. We're talking about this one, right? I know. But if you move the one across, it becomes cotangent squared theta equals to cosecant squared theta minus 1, which is exactly the one that we want. Be fluid, okay, with the identities. Don't be stuck in that mindset. So actually is cotangent squared A. Okay, and from the triangle over here, we can actually figure out what is cotangent squared A lah. First, we have to figure out what is tangent. Okay, what is tangent A? I think
P over square root Q.
okay, P over, I heard square root lah, so I'm just going to do this. P over square root Q squared minus P squared. Okay, therefore, cotangent A will be the terbalik of that. Okay, so cotangent A will be square root of Q squared minus P squared over P. Okay, over P. Over P. So cotangent squared A will be just Q squared minus P squared over P squared. Okay, let's simplify this. It can be simplified because you can split this up. Q squared over P squared minus P squared over P squared. Ini akan jadi 1. So Q squared minus P squared minus 1. Okay, this will be the answer for this. So when we do this, okay, we eliminate the possibility of, ini now. This is very long because you have to find sine A, and then you have to find cosecant A, and then you find cosecant squared A, and then you minus 1, which always brings a lot of problem. Okay, so be fluid. Okay, be fluid with the identities. Okay, why don't you give question C a try? 1 minus secant squared A. Okay, I give you 2 minutes to try this. Remember, be fluid with the identities. Okay, move it around so that kamu boleh ganti ini dengan satu ayat saja. Okay, 1 minus secant squared A, I show you the triangle again. Okay, 2 minutes to answer this. Then I will ask for your answer. Hurry up, people.
Negative P square over Q square minus P square.
Q squared minus P squared. Like this.
Yeah.
1 minus secant squared. 1 minus secant squared is tangent, right? 1 minus secant squared is tangent squared theta. Actually, since we've already found cotangent, right? Actually, it should be the same. It should be just this, tapi kasih terbalik. It should be this lah, kasih terbalik lah. So it should be P squared over Q squared minus P squared. Why do you get negative though? I don't get it. What? Is it negative? It shouldn't be negative.
Kan 1 minus sec square A is equals to negative tan square A.
Negative tan squared A. Oh, yeah. Okay. Negative tangent squared A. All right. Okay. Negative P squared over Q squared minus P squared. Okay, so again, understanding the relationships between all the trigonometric functions. Actually, bila kamu ada sudah ini kan, you don't even need to go and look at the triangle because you've already found cotangent squared A. The relationship between cotangent and tangent is just terbalik. Kalau cotangent adalah ini, tangent adalah ini. And you just switch it around. So, the first step okay, the first step I think which is the most important step is to recognize the relationships between the 6 trigonometric functions, which is the most important thing. Kalau itu kamu belum mahir, okay, that will actually be a very problematic thing. Hold on, let me see if I can find this there. This one. Okay, these 6 trigonometric functions: sine theta, cosecant, cos theta, secant, and then tangent and cotangent. Ini hubungan ini must be inside already. It is not a formula. It is something that kamu kena hafal, macam nombor KP kamu. Okay, you cannot. It's not a. They won't give you this in the formula because it's too low level. You should know this already by now. Of course, the one important one is that we need to remember is tangent theta equals to sine theta over cos theta lah. This will also help us a lot because now we are going to move into proving of identities. Okay, we're going to look at proving of identities. Okay, now when we prove identities, okay, we need to have the three basic identities in mind. And we need to know how to manipulate them around so that we can prove that the left side equals to the right side or the right side equals to the left side, depending on how the identity is written. Okay, so turn with me to page 214. Okay, page 214. Let's start with the first one. A equals to 3 sine squared A minus 2 equals to 1 minus 3 cos squared A. Now, when we are proving identities, we cannot move this around. Dia bukan main pindah kiri ke kanan. No. Okay. What we do is we label this as the left hand side and we label this as the right hand side. So what you need to do is you start with the left hand side, okay, and you manipulate until you finally get the answer of the right hand side. Or, okay, you start with the right hand side and then you manipulate sampai you get the answer on the left hand side. Don't change the left hand side and the right hand side around. Okay, so this is the basic principle of proving identities. You want to prove that the you want to prove that the left side will end up being the right side. Okay, but how do you do that? Okay, let's start with the easiest one first. This one. Let's start with the left hand side, go to the right hand side. Okay, now what is the left hand side? Left hand side is 3 sine squared A minus 2. Follow very closely. Okay, what do we know about the trigonometric identities yang ada melibatkan sine squared A? It is the first identity, kan? Sine squared A plus cos squared A equals to 1. Can I substitute this sine squared A with this identity? Can. But we have to move it around. We have to be fluid, as I said. We have to be fluid with the identities. So cos squared A pindah, I will get sine squared A equals to 1 minus cos squared A. Okay. Then I can bring this in here. So 3 times 1 minus cos squared A minus 2. Okay. Then after that, it's all basic algebra. 3 times 1, 3. 3 times negative cos squared A minus 3 cos squared A minus 2. And then what do we do with this? 3 minus 2, 1. Minus 3 cos squared A, which is the right hand side. Okay, and therefore you can write down here, you can write QED if you want, or you can write proven . Okay, QED is Latin for something. I can't remember what it is, but it means proven okay, in Latin. So you can write QED, you can write proven, or whatever . But this is how we would prove an identity. Okay? But it always starts with really familiarizing yourself. Okay, it really starts with familiarizing yourself with these basic identities. Adakah identity ni akan diberi semasa peperiksaan? I don't know. I don't remember the formula list for KSSM. Tapi saya rasa macam tidak lah. Okay, you have to know this by heart. It's good to know this by heart. Okay, wow. Here am I saying good to know this by heart, tapi saya sendiri pun tidak berapa ingat. Okay, let's try another one. Oh no, what if I start from the right hand side and I go to the left hand side? I can do the same thing if I want. Okay, right hand side is 1 minus 3 cos squared A. This is the right hand side. Okay, the only thing I can do is substitute the cos squared A. Okay, so cos squared A bahkan, so I move the sine squared A across, I'll get 1 minus 3, 1 minus sine squared A. Okay, then after that is basic algebra lah. 3 times 1, 1 minus 3, 3 times this one, but negative plus 3 sine squared A. 1 minus 3 is minus 2 plus 3 sine squared A, and I will get 3 sine squared A minus 2, which is the same as the left-hand side. Okay, you can write QED atau proven, just to flex. Okay, so it doesn't matter which way you do it. Like you start from the left hand, you go to the right. You start from the right hand, you go to the left. Also doesn't matter. But take note, our tanda sama dengan is always at the side. Okay, it's no longer in the middle of somewhere. Okay, too often I see people not knowing how to prove kan. They keep this entire sentence and then just bring the whole thing down as if it's an algebraic equation. Not really, it is not. Okay, it's a trigonometric identity. So it takes some time for us to prove this. But like I said this is really the best way to look at this is to look at this, dia macam satu puzzle. Okay, there's satu puzzle, you have all these clues here. How do I change the clues so that I can put it inside the puzzle and I can manipulate it? Okay, so that's, well, to me, that's where the fun part is lah. Okay, manipulating, kasih masuk supaya dia ngam. It will be ngam one lah. Okay, memang akan ngam. Tiada lah jawapan prove this identity. Then the answer is cannot be proven. Tiada, cannot. It must be able to be proven. Proving identities is a very important skill. Okay, because it teaches us a few things. Number one, it teaches us that the identities are not just formulas, but actually it's very fluid. It can be interchanged. Okay, dia boleh diolah supaya dia, it can be fit into the situation that we want. Okay, secondly, it also trains us to open our minds to think of it, like I said dia macam satu puzzle . Okay, how do I prove that this side is equals to this side dengan maklumat yang saya ada? Okay, and it trains us to be familiar with the identities, okay, and to know how to manipulate the identities around so that you can prove the other side. Okay, so what I want you to do today is to try the identities that are in your workbook. Okay, try the identities that are in your workbook. Workbook page 87. Okay, there's 9 identities over there. Okay, there are 9 identities over there. And I know that you guys have the answer for this. Okay, so what I want you to do is, same thing lah. Okay, finish all the 9 questions. Okay, if you want to refer to your workbook, the answer, you can refer. Okay, but make sure that you understand what is happening. Don't just copy for the sake of copying. Okay, aim to understand what is happening. Okay, and then tomorrow we will do some more proving. Okay, I have an entire bank of proving identity questions. Okay, I love this subtopic very much. Okay, so tomorrow we will do a lot more proving. Start practicing with this workbook and hand in your homework in the Telegram homework channel. Okay.